We present MACS, mass-conditioned 3D hand and object motion synthesis. Hand-object interaction is crucial in our daily lives, involving various uses of our hands. The way we grasp objects is influenced by their physical properties, such as mass. Heavy objects tend to be grasped with the entire palm, while light objects can be manipulated using fingertips. Failing to incorporate these effects into computer graphics motion results in unnatural and plastic-looking motions. However, manually creating such animations considering these subtleties is a laborious task that requires artistic skills. Developing a 3D motion synthesis algorithm that handles these effects would benefit applications like AR and VR, avatar communications, and virtual character animations in computer games. There have been a plethora of research works in this direction. Some of them synthesize static grasps only, whereas others synthesize dynamic object manipulations. Together, none of the existing works considers the influence that arises from object masses. In response to this limitation, we propose the first approach to synthesize 3D object manipulations that faithfully responds to the conditioning object masses. Our work contains three primary contributions. First, we generate hand motions which realistically respond to the weight of the object. Second, our cascaded diffusion-based model can both generate trajectories or accept user-provided trajectories as conditioning. Third, we introduce an approach which ensures that the hands will move the object along a user-provided trajectory with physically plausible dynamics. We now show the comparisons of our MACS approach with the benchmark methods. Compared to the benchmarks, our method produces more realistic grasps while being influenced by the object masses. Similarly, note that our method responds to the object weight by generating hands which hold the light objects from the sides and with the fingertips only, while heavy objects are held from the bottom with full palm surface areas, which greatly increases the realism of the motion. We now compare our method with MANIPNet. MACS shows more stable synthesis in terms of the grasps and plausible hand-object interactions. Note that the ground truth object trajectory and hand rotation and translations are given to MANIPNet as input, in contrast to MACS that does not require these inputs. Here, we show our synthesized motions with interpolated and extrapolated mass. As can be seen, the speed and the range of motions becomes smaller when heavier mass is given. Moreover, the grasp style is also influenced by the conditioning mass. With smaller mass, hands tend to support the fingertips, whereas the whole palm region tends to be used for heavier objects. Our network also synthesizes contact regions on the hand surfaces conditioned on the mass value. With lighter masses, the contact regions tend to concentrate on the fingertips, whereas the contact regions span all over the palm regions when the heavy mass value is given, which follows our intuitive expectations. Here, we show several examples of motion synthesis with object shapes unseen during training. MACS shows reasonable manipulations thanks to the estimated contact transfer. We visualize examples of motion synthesis conditioned on a user-provided object trajectory. Thanks to our ratio net, the object manipulation speed changes based on the conditioning masses. In this visualization, We synthesize sample grasps by interpolating and extrapolating the conditioning masses by fixing the object positions. We visualize 4 instances of each hand to demonstrate the variety in the generated pose with regard to the mass conditioning. Notably, with light mass, the grasp types are diverse, whereas the grasps become more similar when heavier mass is given. This is because a significant palm region is used to support heavy objects. Similar to the previous visualization, we show the sampled grasps averaged over 25 different grasps. As the mass becomes heavier, the hands tend to support the object from the bottom of the objects, which follows common sense. Thank you for watching.